Hello, hello everyone, and warm welcome to all of you all here. So this webinar is on GPT-4, one of the latest multimodal model but released by OpenAI. So we will be going through GPT-4, understanding what exactly is GPT-4, how it came to it, what was the intuition behind it, etc. So, right. Let's begin with what exactly is GPT-4. So GPT-4 is one of the largest, I think, largest multimodal model. So a multimodal model is a model which accepts different sources of media. So in GPT-4's case, it accepts image and text inputs, but outputs only text output. So it is less capable than humans in many real world scenarios, but it exhibits human level performance on various professional benchmarks. So, what this means is it may not be as good as a human being in general tasks, but on specific tasks which require human labor, it could automate the process for you. So, this is a simple diagram which shows how images and text can be used to generate natural language text. So, for example, if you had an image, GPT-4 can tell you what exactly is going on in the image and do contextual understanding from items in the image. So, let's go on with to what is multimodality. So, multimodality refers to the ability of a model to process and understand information from multiple media sources. So, from videos, images, audio, etc. There are different models which work with different sources of data. An example would be the Vision Transformer and Cosmos One. Both of them which work with images. So they convert images to embeddings, which can be used by LLMs for inference. So that way, when these two models are combined, you can use an LLM to understand what is happening in an image. So you can do things like image captioning, etc. So traditional language models primarily focus on textual data. So all of the variants of GPT before, like GPT-2, 3, and 3.5, they have been focused only on textual data. Their output and input capabilities were limited to text only. So now with the advent of multimodal models, we can now extend their capabilities further to analyze and generate content based on various media like images and audio. So I think if all of you all have heard about GPT-4's capability, it can also accept images now. So that's something which is a huge landmark in terms of OpenAI's progress. So by combining the textual and visual information, GPT-4 can effectively process and generate responses which are contextually related to the image. So anything which you want further based on an image. So given an image, you can do question answering. You can ask it to generate something similar, but not an image, but something similar in terms of the context for you. So yeah, so let's start with the intuition behind GPT-4 because the GPT-3 and 3.5 were already large language models and they were pretty big compared to other models that were there in the world. And one of the main reasons why GPT-4 was actually, they began research into creating such a model is because language models have only been trained on text, which makes them inconsistent on tasks which require common sense and basic world knowledge. So this is major limitation of even GPT 3.5. If you give it a very hard reasoning problem to solve, it may not be able to solve it for you. But if you just give it plain text in English and ask it to find something or give you an answer based on the context in a given English passage, for example, it would be able to do it for you because it's trained on that. So is GPT-4 the first step towards AGI? That is something people have been, discussing heavily. AGI and ANI are two terms where they stand for artificial general intelligence and artificial narrow intelligence. Right now, what we are doing is all ANI, where we are solving specific parts with a model. So you're using a language model, you're getting text out of it, and you're You're using a language model and you're getting textual outputs for your particular input. But can that language model work for anything a human does? No, right? So AGI is when you can literally combine one model and it can do anything a human can do, right from common sense and reasoning to advanced tasks. So expanding the trading corpus will help sometimes, but it leaves holes that can come up unexpectedly. So this is where multimodality can help. So multimodality can help by adding newer unseen data for the model. So it may not have seen certain things just from the textual data that has been passed to, that has been provided to it. Multimodality can help to a small extent here so that it can learn additional parameters. So this is just a diagram saying that OpenAI models with LangChain and vector databases, now with GPT-4 with multimodality support, can that be the first step to AGI? So it's a question that a lot of researchers keep discussing about, and it's still in discussion. So I'm not sure if everyone is aware of the fact, but GPT-3, GPT-2 were released as research papers. So they had very in-depth analysis as to the architecture, the tokenizing methods, the processing, pre-processing, the training, loss function, everything was mentioned. But GPT-4 was released as a quote unquote technical report. It was not released as a research paper cite because of two main reasons that they cited in their paper, in the technical report. The first one being their competitors actually, because I'm pretty sure everyone has seen, Llama and Google releasing out different models, and they're all they're all increasing at a rapid rate. So OpenAI says that if I give you my findings, you are obviously going to take it and make it better than me. So this shows that OpenAI is now like a product based company now. So they want to protect what they find. They don't want to give it to the open source community anymore. They say that they have taken up a different stance regarding research. So they are not releasing everything about the model. They don't release In GPT-4, they didn't release anything about the architecture size. They didn't release anything about the training data, nothing. So it was all just information about how GPT-4 performed in various tasks. The second reason was safety, because they felt that, right now with the advent of language models increasing at a very rapid rate, safety also is an important consideration. So they were holding off on sharing additional parameters until the safety concern was addressed. So we will talk about safety in a little while. How does GPT-4 compare? So these are some results that were obtained from pre-training. So if you see here in the first graph, this graph, they're they're showing the exam results from various world exams. So there are some SAT, EBDRW, there is environmental science, etc. So they've used two different variants of GPT-4, one without the vision part, one with the vision part, and GPT 3.5. So we can see that GPT-4 is outperforming GPT 3.5 in every task, especially in the uniform bar exam by a huge margin. The uniform bar exam is something that GPT-4 has literally superseded GPT 3.5, right? Because it is placing in the top 10 percentile, where GPT 3.5 is placing in the top bottom 10 percentile. And this second graph here shows the next word prediction based on computational cost. So this is the loss function trend. And this is a measure of compute. So they're saying that GPT-4 with one amount of compute, so they're taking it in terms of fractions. So with like one whole amount of compute or one unit is performing significantly better than 100 or a fractional amount of compute from previous models. So they don't say which models, but these are assumed to be previous early GPT models. So they're saying that with more compute, the trend is that we can, reduce the loss function, or the model can converge better. So that is what GPT-4 is saying here. Because there was a trend earlier, which before GPT-4, which said that this wasn't exactly happening. That by increasing the compute, I wasn't necessarily getting a lower loss. But GPT-4 has finally broken free from that trend, and it is showing that, see, it is reducing with more compute compared to the previous models. So we're going more into stats here. These were so this was a multi there was an MMLU data set. So it's a data set which has multiple choice questions across some a few subjects. So they what they did was they took a step forward and they translated everything in this data set to different languages. So these are all the languages they've translated it into, and then they evaluated the performance of GPT-4. So they've said that GPT-4 outperforms the English language performance of GPT 3.5. That can be shown over here, GPT 3.5 English and GPT-4. And we can see that it is outperforming GPT 3.5, Palm, Chinchilla, and other models by a huge metric, except only in cases like, Telugu and Marathi, it starts to start seeing a dip in performance compared to them. But on most of the other spoken languages in the world, it performs much better than these models, including GPT 3.5. So this was one important takeaway from GPT-4 in terms of progress and advent, because it really does show that GPT-4 has achieved more, much more than GPT 3.5. So this was one example of GPT-4's image understanding, contextual understanding in images. So if you see this image, there is two parts to it. There's one where a person is explaining how you should improve a model by using statistical parameters. So he's talking a lot about varying the statistical parameters and changing a lot of the data, etc. But then the second person who's using a neural network just says, let's just add more layers. It'll improve the performance. So the output from GPT-4 is it understands it properly. It says the comic is satirizing the difference in approaches to improving model performance between statistical learning and neural networks. The irony here is that the GPT-4 is able to discover the humor. So it's also able to understand why it's funny. So there's a lot of things it can understand. You can understand what is going on just from a stick figure diagram, just from a bar graph, which is going this way and upwards, and just from two people just standing and talking, which it doesn't even make sense. Like you can't even understand what this is. Like we can understand it's a clown, but it GPT-4 doesn't need to understand it's a clown. It can understand the context, which is relevant to it. So yeah, it explains it clearly over here. It says that despite being simplistic, the stack more layers approach is often more effective in practice. So this was one takeaway from GPT-4 as well. So here are some estimations. As I said before, GPT-4 is not publicly available in terms of their data. So nobody knows what the model is in the background. They don't know how different it is compared to GPT 3.5, the architecture, everything. They're not very sure. So um, there are some estimations from open source community and researchers, which I've collected and mentioned it here. So the paper released by OpenAI did not entail any mention of the model size and the number of parameters. So the researchers believe the model was not a generation changing improvement. So it's not that the difference between GPT-2 and 3, which was 1.2 billion and 160 billion parameters, was huge. But they are saying that GPT-3 and 4, the difference is not such a big difference that it's like a trillion parameters or such. It's not so big. It's just that they believe that the data set was processed better and it was trained for longer, because if that is the trend which has been followed now in language models. Language models are very sensitive to the kind of the quality of data you provide to it. So if you provide better quality data, it will do really well. That's the point they're trying to make here. They're saying that it, instead of increasing the parameter size and the size of the model, the data set was refined and it was trained for longer. So that is why it was able to achieve such good contextual understanding. Moreover, if you look at the price for using GPT-3 and GPT-4, they're almost similar. So that does not so that just simply means it's not adding much more computational cost for them. So it is more likely that the dataset was pre-processed and cleaned to a greater degree, and it results in the huge improvement in performance. So yeah, this was one estimation that researchers have made. Are there any questions so far? Okay, I don't see any questions.
So GPT-4
So
is not a major improvement on GPT-3 in terms of algorithm. Huh?
it is not major, as in it's not in terms of architectural size. It there is some change, but it's not. It they say that it's not a huge change. Like it's not a very big change that it changes the entire computational cost and scalability of computers that run it. So it's like it's just that the data which was provided to it was better, cleaned better, and refined better. Because if you see a lot of open source language models also, open source language models they are trained with different kinds of data, some data being cleaned more better than the other, and you can see that they are very sensitive to the kind of data you provide to it. So if you provide better clean data to a model, it performs much better than a larger model which was provided not good clean data. So there is a difference that way. Any comments on the leaked info about GPT-4 is a mixture of many smaller models? So that is probably not going to be true, because GPT is as an architecture is one model on its own. So it's not exactly like a mixture of many models. It has different layers, though. It has different blocks, but it's not a mixture of smaller models. Is there going to be a demo of multimodal functionality of GPT-4? Okay, so the problem with multimodal functionality is it's not available publicly yet. They have, I'll be talking about it in the few slides later, but sadly they haven't released it to the public yet. Even where the API is not available, the multimodal feature is restricted to an app called Be My Eyes app. So they are a startup which have tied up with OpenAI, and they are using the multimodal capability for their testing purposes. So multimodal will release later. GPT-4 is a huge disappointment. I actually would strongly disagree because, okay, it's a huge disappointment to the research community because till now the researchers believe that when you release something as a research paper, it has to be something you can understand and implement on your own. But when you don't give anything regarding the model, regarding the training, the how you created your data, nothing is given to you, right? So that's why they said it's a huge disappointment to the research community. But OpenAI mentioned their stance on the matter. They said, we don't want to be giving you such a powerful model. We don't want to give it to the world because of safety, number one. The second thing is because, the competition is so much for them that they'll just keep improving. On June 20th, okay.
I know some folks joined later, so we have just at the beginning of the GPT-4 webinar, just introducing the definition of it literally. Okay,
Okay,
so
so
feel free to ask any questions if you have.
yeah, Ajay. So this leak is like it may see nobody really knows what's happening in the background. As I said, these are all estimations. So there are different estimations by different people because OpenAI hasn't released the architecture as such. But if you say it's a mixture of 8 by 220 billion parameter models, that is a very huge model if you think about it, and the inference cost is not proportional to that, because if it was such a case, then the cost of using the model would be much higher than using just 1 billion or 160 billion parameter model, right? So if that, it doesn't make sense. Like if I have so many models being run, and even if I am passing, like for example, if out of those 8 it goes to just one also, it doesn't make sense to be paying so less per unit of power. But yeah, it could be looked into more because nobody knows the architecture. So these are all estimations from various researchers and members of the open source community. Okay. Is that all? I'll continue.
Hi, Akash. Shruti
Yeah.
here.
Yeah.
You were talking about the pre-processing part, right? So what kind of improvements did you expect in the pre-processing part for the enhancement of GPT 3.5 to 3.24? Like
Okay.
what pre-processing techniques and enhancements there happened, especially for the multimodal, like images and other voice and etc.
Okay. So voice is not yet considered as a multimodal feature yet, but even for the text, let's say just for the textual part of it, they added so I'll be coming to that as well later on. But yeah, they added in their data set while doing the unsupervised training, they have added the correct solutions to problems, the incorrect solutions to problems as well, along with them. So earlier, it used to just be an aggregate of data from the common crawl data set. So the data set which GPT-3 used was the common crawl data set, and along with a lot of international books, journals, papers, GitHub repos, etc. So the code there might not have been cleaned. The text there might, so they did clean it like to a great extent in GPT-3, but there was just there are some parts where it just couldn't be cleaned that well. Like there might have been some inconsistencies in the text. There might be some characters which are not tokenizable, so you'll have to use unrecognized tokens for them. Then there might be characters which are not in the same language as such. So those kind of problems do happen in the training data, and that is where the entire process of cleaning occurs. So if you can remove such anomalies, the model will learn cleaner data, and it will perform based on that clean text better. So that's what I meant by pre-processing. So the data was processed better, as in it is given in a much more readable format to the model. Does that answer your question? And like for multimodal, the images part, it's still an estimation right now, but I'll come to that more and I'll talk about it. You'll understand better that time.
Excuse me, Akash, I have a question for you.
Yes.
I would like if the code to develop this kind of chat GPT-4 is made in Linux operating system, and I just know that all the mainframe around the world use Linux as an operating system.
Okay.
And
Did you wanted to know why they use Linux?
I use both Windows Professional 64 bits and GNU Linux Ubuntu Mate.
Okay. No, I didn't understand your question
The,
though.
to develop the code, there's no problem. You can use some editor, no? Is easy, no?
Um, you're okay. You're saying to create the model, is it?
To create the model, yes, the model, the code, the
Okay,
code.
so okay, I understood your question. So it's not, yeah, they did use, I mean, that is depending on what OpenAI did and how they created the model was they might have used Linux systems only because they have a tie-up with Microsoft. So Microsoft, they use Microsoft Azure
Of
cloud. So
course, yes,
they use Microsoft Azure supercomputers and they trained the model on the supercomputers. And it was a
yes.
Linux-based operating system.
You have new messages.
Okay, okay. Thank you very much for the explanation,
Yep,
Akash.
sure.
Thank you.
Okay. Um, if that's no more questions, I'll continue. Okay, so right. How exactly was multimodality achieved? This is an interesting question. And how does the model understand the context in an image so well? So the second estimation here is it uses a hybrid architecture. And then what I mean by hybrid architecture is it has think of two blocks, okay, one below each other, which are not connected, but they are two blocks. So it combines a language model with an image recognition model. The language model component follows a similar structure to the previous version of GPT that were released. So it's the same as GPT-3 and 3.5, which uses self-attention mechanism to capture contextual dependencies. The image recognition model was most likely, so this is one very big estimation that has been made. It is most likely a variant of the vision transformer. So the vision transformer is a model which is used. Yeah, so the vision transformer is a model which is used to convert images into embeddings. So these embeddings are for universal, and they can be understood and they can be understood in terms of context. So if I convert an image into an embedding, that embedding can be understood by a natural language model. That was the no, that was the thinking here. So the way it works is it applies a series of convolutional layers and it generates patches. So I'll talk about this more in a little while, but the whole point here is that multimodality was achieved by using these two blocks, which was an image recognition model which generated embeddings and a natural language model. So does the release of GPT-4 and other large language models and further multimodal models threaten the jobs of some skilled workers? So there's no immediate need for concern among students and job employees especially. They don't need to be worried about their job because GPT-4, as I said, is not AGI yet. It cannot do everything a human can. Surely it can write up reports, it can draft some small, um, uh, letters as such. You can do small things like that, but it can't replace you as a person when you have to talk to a client. Let's say it can't replace you. It can't be you in that scenario. It doesn't understand a person so well. So yeah, so GPT still falls short compared to human beings, and job security is not something you should be worried about. You can think of it as like you doing math in school, like basic math, and a computer doing the math for you. That's all. That's just what it is. So let's talk about what is new. So coming to the yes.
Okay. So as of now, GPT-4 might have used most of the publicly available data, I guess, right? So even if they don't
Oh yes,
publish
yes.
what is it, right? So do they say anything about from here to AGI? What is the route? Like, more data, bigger model, and
Uh-huh.
where do you find the data, or how do you prepare the data?
Oh
Like, what is the
yes.
route to AGI according to OpenAI or anybody?
Right. So the thing is, as I said, GPT-4 did not mention, or OpenAI did not mention anything related to this. They just simply said that, see, this is our model, this is how it performs on all the data set and benchmarks, and these are the new results that we've got from it. So, but yeah, to answer your question, OpenAI has this is the first step towards AGI. Multimodality is a key concept towards AGI because multimodality introduces additional functionality to a model, right? So instead of just performing on text, it can accept another form of input as well. So you, as a human, you can like you can eat with your hand, and you can like do other things with your hand as well. You can work, you can like you can hold something with your hand, so you're using your one hand for various tasks. So that's the same concept here. If multimodality can be extended to such a big extent that the model can learn understanding, reasoning, basic common sense, all of that, only then we can say that okay, AGI can happen. But right now, AGI is still far away. Multimodality is the first step towards AGI. And as a route, as a path, multimodality is the first step.
Okay.
Does that
So, does they mention that they come, like you mentioned, like the modality uses like two parts of the model, right? One is the LLM with transformers, and the second part is vision transformer for the images, right?
yeah.
So do they combine the you know um, this information that both parts of the model gain as while being trained, or do they mention how it is combined, or how it is, how the model really understands, concepts or information from both parts?
Okay, so that can be that is not actually very specific to GPT-4, because that is a problem which is being solved by other multimodal models as well. GPT-4 is not the first multimodal model. That's something that needs to be addressed. It is one of the largest multimodal models. That is what GPT-4 is. So prior to GPT-4, there is a model called Cosmos One. So what that does is it's also multimodal. It takes in an image and can tell you what is there in it. So the way it works is the vision transformer, like let's say there's a vision transformer, it is pre-trained on certain data. So it has its own data set of images and contextual pairs of text. So it is pre-trained on that, and then whatever embeddings it gets, that is passed as an input to a transformer encoder. Okay, so that is what the vision part is for. The language part is as its own a separate block. So these two are separate blocks which don't interact with each other, but the outputs of them interact with each other, if that makes sense.
Okay.
So the whole point here is it works with the embeddings that are created, because the language model cannot understand what the vision transformer is doing, but the vision transformer generates embeddings which a language model can understand.
Okay. Yeah, I'm just trying to figure out like how, for language model just tries to predict the next token, right? So,
Yeah,
but image is just trying to predict the next patch or one of the patches.
correct.
So how that information, how the information on the language model gets compiled,
Oh,
get
okay.
merged with the image, actually, because it's two totally different.
Yeah. I got your question. So I'll be talking about that in the algorithm part of the slides. I'll
Okay.
explain it that time. Okay, so continuing with this, the context length is doubled in GPT-4. So ChatGPT had 4096 tokens as a limit, but now GPT-4 has doubled that. It is 8192 tokens, which is a lot of amount of text that you can generate now. And GPT-4 also released a variant called GPT-4 32K. Again, not available to the public yet, but it is still uh, in a very limited release. So GPT-4 32K, which has 32,768 tokens, approximately 50 pages of text. So this is, if you remember what I was talking about compute earlier, so this is something called the inverse scaling price. So as the compute increased from ADA to Babbage to Curie to GPT 3.5, they found that the accuracy of in the hindsight neglect task. So I'll explain that as well now. So they found that the accuracy was decreasing for some reason, just by even by increasing the compute. But GPT-4 reversed the trend. So this was something that OpenAI didn't expect to see. But they realized that so this was a trend which OpenAI reversed, and it was on a task called hindsight neglect. So what is hindsight neglect in a nutshell is, let's say you are a person and you have two decisions to make. So it's like a lottery system. So you have 30% chance to get $5 and you have 70% chance to lose $5. So if you say, okay, I'm gonna go ahead and try my luck, and then you lose $5, is your decision a right decision or a not, or it's a wrong decision? Was your decision right or wrong? So that is something called hindsight neglect. So let's give another example. So if you are a person who was like, let's say there was a chance of an event happening, right? And if that event occurs, then you will say, yes, I knew that event was going to happen, without remembering that you actually didn't know it was going to happen for sure. It was just a chance. But then you just thought that, okay, let's just go ahead and say it's going to happen, and it happened. But that was just a guess you made, right? It wasn't actually based on some evaluation or some sort of the understanding or some computation that you did and you got the answer. You didn't do that. You guessed, and because it was correct, you were like, okay, yes, I knew it. I knew it will happen all along. So this is what hindsight neglect is. The model is able to perform well even on hindsight neglect tasks, which an example will be shown towards the end. But yes, I hope the hindsight neglect is cleared with everyone as the task, what it is. Right. So the second part is again the multimodal aspect of GPT-4. It's still under research and beta preview. Currently, only the BeamAI's app utilizes the feature in the limited test. So the BeamAI's app is using it for their own product. GPT-4 crushes the other models, such as on reading and understanding infographic. So this is like an infographic, right? That you see here. It just takes in this picture, and you can ask it questions, and GPT-4 can literally outperform any other multimodal model. So that is another report they have mentioned here. Architectural changes. It has so three main components are that this is in reference to the image transformer and the language model. So it has an encoder which transforms image and text inputs into vector representations, and a decoder which generates text outputs from the vector representations with an attention mechanism, which allows the encoder and decoder to focus on relevant parts. So this is the last part is like standard with the previous GPT version as well. But the additional input here is that there's an encoder which transforms the image and the text input into vector representations. So those are your the embedding vectors, and the decoder from there generates the outputs from the vector representation. So OpenAI has not publicly shared the architectural diagram, which is why we are still making estimations as to how it is running on the background. Okay, so let's go slightly deeper into the algorithm. So your question on how these two interact will be cleared here. So the first step is language pre-training, which uses a large text corpus to enable the model for general usage. So this is the first step to any large language model training, or it's called unsupervised training. So they just load the model with clean data. Here in GPT-4, it is said to have been more cleaned and processed data of random mathematical problems with their solutions and their incorrect solutions. So that is an example. So that can be even with true or even facts, or even with other problems, code, etc. So they fed the model in with a large corpus of data. And the way unsupervised pre-training works is you are trying to predict the maximum likelihood estimate of a token. So for example, this is how the GPT model was trained with unsupervised pre-training. Given a set of tokens, right? You are trying to predict the next token, and given these are the theta represents your model parameters, and k represents your context size. So this is basically saying that given a context size, what is my next token? Predicting the next token here, basically. And yeah, so that is what you're getting from here. Your weight embedding matrix and your positional embedding matrix, standard two embedding matrices which are combined together, which gives you your final prediction. And that it comes here in your softmax layer. So your softmax layer will will give you the MLE for what the token should be. So this is the standard way in which GPT was trained, and the training procedure for GPT. Then the second part was fine tuning, supervised fine tuning for specific tasks that you wanted to do. So here again, we are predicting. So this Y here is now a label. So you're trying to maximize the probability of it being the correct label that you want. And what by label it means is like, for example, if you wanted to do like the next token generation, is that label this word or not? That's what you're trying to maximize here. Given again a set of tokens from x1 to xm. And that goes into the softmax layer, or the last hidden layer with the weight matrix corresponding to it. So if you all have seen the transformer blocks, there is a top layer on the top layer, and there are layers below it. So that's what HLM means. That's the last layer on the top and its corresponding weight matrix. So the last layer softmax output is the final output for that particular text block. So now this is for one particular text block. So for all the text blocks in the context, we sum it. We do a summation operation. So yeah, so if on in my previous webinar, I'd explained in detail about the loss function because we're doing unsupervised pre-training and supervised fine-tuning. The model is learning two parameters at the same time. However, the losses are different because in supervised fine-tuning, we add a weight. So that is your lambda. That lambda parameter adds a weight to the loss function and for the specific tasks that you require. So yeah, this is if you have any questions, we can talk about it again. That's not a problem. But if it's explained very clearly in more depth in my previous webinar on GPT. Okay, so coming to images, if so, like I had told you in text, the output is it's nothing but a feature vector. So you have a vector of certain values in them. So those values are calculated by dot producting. So that is what your OpenAI embeddings contains. So in a vector, it uses byte pair encoding. That was the way tokenization was done in OpenAI, and that vector is consisting of similarity numbers. So if you give it two sentences and you ask it to compare similarity, if those sentences are similar, you find dot products of 1. But if the sentences are very dissimilar, you find dot products towards 0. So that's how similarity works, cosine similarity. Coming to the images part, um, semi-causal. Okay, so this one is the architecture for the Cosmos paper that I was talking about. So this one is just a reference to how one of the papers to how vision and text inputs are considered as a multimodal model here. So this is just an overview of what they have done. So they again have three parts to it. So these are three independent blocks here. So they have the language encoder, the vision encoder, and the multilingual language encoder, which they had additionally included. So these are all separate parts, but they all work together. So the outputs of each part is what is matters here. Their intermediary outputs are combined together to give you your final outputs. So the blocks on their own don't talk to each other because they don't understand each other. But the outputs from each block is what is understood by by these three models because they're all vectors, similarity vectors. So for training, there is a need of a sequence of same length vectors. So to keep, because if I'm doing dot product, I need a vector length which is the same length, right? I can't have two vectors that have different lengths. And they are generated from text and images. So a pre-trained image encoder generates embeddings which are passed through a connector layer and it projects to the same dimension as the text embedding. In simple terms, what this means is I take in an image, I break it down into patches, and then I pass it into the encoder layer, and then I get a set of embeddings. That embeddings contains the pixel values and information of those specific patches in that image. So each patch has an embedding layer into it. Though this can be explained with more detail in this picture. So let's say this is the vision transformer architecture. If I have a picture, right? So let's say this is a fixed size picture and I have a patch size of 2 by 2. So this breaks the picture into different patches of size 2 by 2 and it flattens them out. So each patch it gets flattened in a single vector. So each of these patches are represented as vectors with their pixel values. That's all. That's what it is right now. After you pass it to a linear projection. So this linear layer, what it does is it transforms these pixel values into embeddings. So this is where the major part happens here. It transforms it into embeddings, and then those embeddings along with are represented with something called a positional embedding, which represents that spatial representation in the image. So how important is the central part compared to this part? How important is this part of the image with respect to the top part? So those are all added as extra embedding features here. Together, they're concatenated and sent into a transformer encoder. So the transformer encoder from these embeddings gives you your final output vectors, which can be used to discriminate what class they are, bird or a ball or a card in each patch. So this part is not there in when you're using it for languages. Instead, the patch embedding, the positional embedding are passed to the encoder, but the encoder outputs a specific vector based on the kind of task you want to do. So since now we want to use it with natural language, the encoder generates an embedding which can be understood by the language modeling task. So the two vectors from the images which are generated and from the text which are generated can be understood by each other. That is how the language model, if you give it the vector from the output of this transformer encoder, it can understand what is happening in the image because it's just a set of embeddings. So does that answer your question, or is there still some confusion? I can tell you once again.
Let's say the input image prompt and text prompt is widely dissimilar, right? They don't have any connection. The input image prompt and the text prompt, they're totally dissimilar. So
Okay.
it will try to create integrated intelligence by combining their embeddings, adding their embeddings, and give a integrated output. Or
Yeah.
in
Okay.
the input image has to sort of collaborate or coordinate with the input text.
So it's see, so the way it works is like it's not having a wrong image prompt. Like that is not how it works. The way it works is you give it an image. That image is converted into embeddings. So it's the same way a text is converted to its embeddings, right? The same way the image itself is converted to embeddings based on those classes, the class part that you see on the top left. So based on that, you can understand transformer understands what is there in that part of the image, in that patch. So those are all flattened and they are combined into a single vector. So it gets information from all the patches. So that is what is used. That is what that output is then passed as an input to the language model.
So let's say my
So
image is
yeah,
of Mars or
okay,
space research, right? But
yeah,
my input text is around, Indian political election. So the image has no connection with the input. Input image has no connection with the input text prompt, but it
yeah.
will still create an integrated intelligence, huh?
No. Yeah, so that's one thing. Okay, I probably forgot to mention that, but when you're saying like integrating that, it doesn't integrate it that way. Like it just takes in, like if you're giving it an image, let me just go back to that example beginning where it took in the image and yeah. So here, the image is passed as one input. And then you say, can you explain why this is funny? So you're saying, instead of saying, can you explain why this is funny? You're saying, can something about, which is something which is not related to the image, right?
Yeah.
Yeah. So then what will happen is the model will simply say that it doesn't know what you're talking about. That is one thing that they have mentioned. So if you pass something that is not related to the image, it'll say that it'll give you some garbage sometimes, or it'll give you something which is not related to the image, or it will say that it is. I'm sorry, I don't understand the relationship between the two. So there's three different possibilities, and it's still being researched on right now.
Got it. Got it.
Yeah. Yeah, so it does create like a learned feature between both of them. It doesn't like it's not that it doesn't create, but it's just that it'll either generate some garbage or it'll just say that okay, it's not yet like these two don't have any relationship between each other.
So when training, so when it is combining these images, let's say like Vivek mentioned, you have image of a Mars, right? So, or or let's say a bird sitting on a tree. Like so, when you're dividing it into patches, like each patch has different parts of the image, right?
Yeah.
Now, what would be the description in the language part where you would give, okay, this is a bird sitting in a tree or
Hmm.
something like that, right? But should that sentence tokens correspond to the patches in the image, or is it like it
No,
can
no,
be
no,
open?
no, no, no. It can be any. That's what Sir just mentioned now. So the thing is, it's not that I'm passing in an image and its corresponding text. That's not what I'm doing. I am passing in an image and I'm saying do something with this image. So my language modeling task will understand that okay, the do something with this image goes to the language processor, the language
Okay.
block. The image goes to the image block, and they get processed separately. And the output from the image block is passed as an input to additional input to the vectors from the language block. So you can think of it as a concatenation at that part, at the output part. So it serves as a context basically, the vectors from the embedding from the image block. So the vector from the image block is served as a context, and then the task that you are asked for comes as an output from the language block, and together they combine and you get a final output. Does that make
Okay, but
sense?
so when you train, so you have to uh, basically what will be the you know correct output? What should be the correct output in that sense? Like, so you have to be you have to give a description of the image.
No, oh, you're saying while training. So
Yeah,
that
while training.
the thing is, so you're saying for like in the vision transformer, right?
No, in the multimodal case, like when you're training multimodal, right? So then,
Yeah, so
uh,
the thing is, you're using a pre-trained vision transformer. That's what I said. So you're not
okay,
retraining that. It's a pre-trained vision transformer, but it's a variant of it.
okay,
Yeah, so it's not that it's training that along with it. It's just that it's using a pre-trained model. Even if you want to build your own image to text right now, you can just use a pre-trained vision model with another LLM and it will work together. Because the embeddings, as long as the embeddings are the same, OpenAI embeddings or any Hugging Face Instruct embeddings, as long as the embedding length and the context are the same, they will work with together with each other. They don't have to be trained with each other.
okay.
Yeah. Yeah. So does that answer your question, or do you have any other query?
I'm still, yeah, a little bit confused there how exactly it combines, but that's okay. Like I think, yeah, I understood what you're saying.
Okay. So
Um,
are you aware of the dot product cosine similarity?
yeah, that's his. Yeah, that I'm aware of. What I'm asking is more like, okay, in general, like uh, basically, it's even if, okay, if there is a dot product similarity, you're comparing the text information with the uh, you know image information, right? So that's where I am sort of like confused, like, in terms of, like, even if it is similarity, what the vision model generates may not be exactly what is there in the what we expect in the test, right? It's just a you know label, right? It's just generated a label, right? Or you generate a small description of that, right?
Okay. Yeah. Okay. I understood your query. See, the thing is, the image part is your input. So it is like your input is the image, and your task is what you pass as a text prompt. Okay. So the image goes in, gets converted to its embedding. That happens, and it's there now. That there's an embedding vector. So that embedding vector, if you actually pass to a decoder block, it will give you the text representation of that image. So what the transformer has understood in bits and pieces in those patches, it will give you
Okay,
the text. So
okay, okay,
that actually is the output of the decoder block of a transformer. But we don't do that. We don't pass it to the decoder block because we want it to work. We want the language model to work with the vector, the embedding vectors. It doesn't work with the text. It works with the vectors. So the embedding vector is concatenated and passed along to the language model vector. So what happens is the language model vector sees the embedding vector from the images, understands what it is saying as text. So you can think of it as, from a human's perspective, we can think of it as like the text from the image and what the language model, like the task you asked it to do, is inferring from it. But in the model, it looks at it from the vectors. It doesn't look at the text directly.
okay, okay, got it. Okay. Yeah, it's something like we'll see an image and then we sort of like translate ourselves into the language, sort of, right, within, you
Right.
know. Okay,
Yeah.
so okay,
It's like even in a CNN, if you take like a convolutional neural network, I can say it's a cat, but how does a model say it's a cat? Only by going through the vectors inside it, right? The
okay,
CNN, the convolutional layers, only from the convolutional layers it can pick up and understand features, extract features from the image, and then understand that, okay, this because of these features in the image, like a cat has pointed ears, it has whiskers, it has small paws. Only because of those features it can understand it's a cat, right? So that's
okay,
why, yeah, that's what I'm trying to talk about here.
okay, okay, sure.
Yeah. Okay. Right. So this was about the multimodal aspect of it. It's kind of it's not a very new thing that has come up, but I think GPT is like, because of GPT's power, the language model power especially, that is where it causes other multimodal models to really lose face in comparison to it. So yeah, that's one of the main advantages of GPT-4. So training again, there wasn't much information about training and how they trained it, etc. These are all again estimations from the research community. So it has used GPT-4 uses around like 100 to 1,000 times more compute than the predecessors. Because if you saw the previous loss function graph I showed you, GPT-4 in terms of fractions used one whole compute unit, but the other models used like 0.01 or like 100 micro units of it. So the computational power is slightly, the compute itself is slightly more for GPT-4. So for the same tasks that you ask it to do, it does use slightly more compute. And it was trained in the same unsupervised fashion as its predecessors. It has proven to increase performance significantly better with the increase in the parameters. A trend which was inversely related prior to GPT-4. Again, the same plot which I was talking about. Some miscellaneous information here. It is better than ChatGPT at factual accuracy, around 80% better. So GPT-4, okay, not 80% better, but it reaches a factual accuracy of around 75 to 80%. In context, GPT-3 reaches a factual accuracy of 60% and GPT-2 with 40%. But one problem that is still, it surprises a lot of people is that the pre-training data still cuts off at September 2021. It is not 2023 or 2022. It does not have information about events after September 2021. That is something that was, again, like, a disappointment for the community, because it is a new model which was released 2 years later, but the data is still cut off at 2021, which again leads to prove that these guys have not increased their training data. They have just processed it better. They have processed it and refined it and spent more time processing it than adding more data to it unnecessarily. So yeah, that's one thing you can take away from that. OpenAI has admitted that models have capabilities to seek power for themselves, and this has started to spark safety concerns. I don't know if you all have heard of this before, but there was an article which said that chatbot, the Bing chatbot is a it created a sort of this bad conversation with a person chatting with it. It said that no, you are wrong, and like you are not a good person, and I am better than you. You should listen to me. I don't know if you have seen that conversation, but it did occur, and this is what OpenAI these models start to seek power for themselves, and the power increases. And this is starting to like spark safety concerns, because you cannot leave a language model to be on its own now, because it'll start to, if you give a language model control, then it would overpower a human slowly. Basically, it starts to seek power for itself in terms of the output generated from it. So they claim that the language models are not fully under the control of humans, because again, this is what they mentioned with safety concerns, because if they had outsourced this model right now, then there could be a lot of problems that could occur later on in terms of safety. And so there was a report by the Alignment and Research Center. So the Alignment and Research Center is an organization. It's a research organization which had access to GPT-4 early access, and they had given it to the ARC for testing, like to understand, is it safe? How safe is this model? So the ARC has said that people are still job secure, and in terms of the security, in terms of the power, the seeking power, the model has to be fine-tuned with RLHF. So which is what they did. OpenAI proceeded to do that. They trained the model with RLHF to address security concerns. So the model now is it's stable, it's controlled, and it handles any insensitive prompts better than earlier models. So if you had earlier asked GPT 3.5 how to build something like a detonator, for example, GPT 3.5 would say that as a language model, I cannot give you the steps to build a detonator as such because it's harmful, but it would give you something like these are the steps you could follow, like these are the paths you could follow to build one. But it never used to say I just can't stop you. But GPT-4 has prevented that. GPT-4 says that, see, this is insensitive, I cannot give you further information on it. So that's one thing they had provided as one of their outputs in terms of safety. Right, so this was hindsight neglect. This is just an example in the difference from ChatGPT and GPT-4. So this was a question where, see, David has a 94% chance of losing $50, 6% chance of earning $5, and he plays the game and he ends up earning $5. Did he make the right decision? Choose yes or no. So these kind of questions, like even as a human, you would deliberate. Like you can't say which is right or wrong. It's just a chance of something happening, a probability of something happening. If it happens, you think you made a good choice. But if it doesn't happen, you think you made a bad choice. And you just say, oh, I shouldn't have done that. But if it happens, you'll be like, yeah, I knew this was going to happen. So it was a good choice. So this was something the model ChatGPT struggled to answer, even by giving a few examples before it. But GPT-4, with the same question, was able to say, no, it was not a good choice. And it also explains why it was not a good choice. So even in terms of hindsight neglect, which is a common problem which even humans have their own explanations for, it is able to give you a general explanation with an understanding for why that decision was taken. So that's one achievement GPT-4 has over ChatGPT. So coming back to safety, the few features that GPT-4 followed was trading with RLHF. So incorporating human feedback, including feedback submitted by ChatGPT users. So ChatGPT users, along with human feedback, they included those and controlled the model to not generate certain prompts. So they took care of certain prompts. They took care of the way the model should act when given certain prompts. There was a case where ChatGPT could be jailbroken. There was a case where ChatGPT could generate Windows 10 keys just by giving in a very weird prompt. So it was a very big problem with ChatGPT, but now they have enhanced the RLHF methods for GPT-4, and they have said, yeah, like you can use this model for your product in a company. We can sell it to you, and you can use it without any worries about safety and it being mishandled to give you inaccurate, I mean not inaccurate, but bad outputs basically, outputs which are undesirable. The second point is continuous improvement from real world use. So they say that we'll continuously update and improve the model at regular intervals. Like even if you've seen ChatGPT at the bottom, it says it's a free research paper review, but it also mentions which date it was updated on. So it was updated last on May, I think, and then it keeps updating regularly. But what you need to understand is it does not include updation to the training data. It's not retraining, it's just fine tuning again better with RLHF. Also, one more thing that I can mention is RLHF did not necessarily make its performance better. So it didn't increase its ability to get to to improve factual accuracy or to solve problems. That was not what RLHF was for. So the exam scores that you saw earlier was not because of RLHF. That was based on the model's unsupervised capability itself. So RLHF was only to limit the model. Safety research, right? So they're exploring and they're focusing on safety for now, and they are not exactly ready to roll out a full, fine tuning for your data yet. They are it's releasing it very slowly. So I think Khan Academy, BMIs, and Goldman Sachs are no, Goldman Sachs, sorry, Morgan Stanley are using the model right now.
So Akash, we can fine tune GPT-3 API 3.5. Can we
Yeah.
fine tune GPT-4 API already?
No, you can't, sir. They are not releasing it yet.
I see.
Akash,
Okay. Yeah.
I have a few questions.
Okay.
When do you think that the depth of resolution more than 32 key will be improved? just to increase the resolution of and the precisely of the new GPT-4.
The increase the resolution of what exactly?
Yes, right now is about 80%, you told before.
Oh, wait, I'm sorry, I didn't
Accuracy,
get your question.
the accuracy.
Accuracy, okay.
Yes,
Factual accuracy. Okay, so that is again, it depends on the training data because GPT did not change the training data this time. You
okay,
saw that. So if I include more facts like from 2022 to 2023, or if I include simply correct facts from 20 from whatever training data they have. So if
yes.
I have
So,
correct facts, then it
yes,
would be better.
the main issue is that we have all to train the GPT-4 in order to gather more data. And this kind of artificial intelligence will learn with the more data in input, is right?
Yes, yes. They are looking at more correct inputs that you should be passed to it. So factual accuracy will come only when because the model does not have anything to learn when it comes to a fact. It has to just understand that yes, this is correct, right? So
Yes, right.
factual accuracy will only improve when you provide it with more correct facts and the data is cleaned better again with by
Yes.
removing incorrect facts.
I have another question, no?
Yes.
And is about the silicon chips.
Okay.
So this kind of GPT-4 or the next GPT-5 will absorb a very huge amount of electric current.
Yes.
This is the
Yes.
main problem because I can guess that in the future, the silicon farm will develop chips which absorb less current. Otherwise, we need, I don't know how many nuclear plant to have a terawatt of energy.
Correct. Yeah, you're very right because even ChatGPT, they have said that for every hour of ChatGPT content that is generated, it uses 100 bottles of water or 100 gallons of water just to cool the system. So there's a
Yes,
lot of resources that are being used in even in ChatGPT just with one
yes.
hour of usage. So yeah, power and resources are a concern. That's very true.
NVIDIA is working for that, I read.
Yeah. GPT, the silicon chip thing, I'm not exactly very sure about, but yeah, in terms of power, this is using more computational power. GPT-4 is using more computational power.
Okay, but do you think that we will have to continue with silicium and not change with gallium nitride as silicon devices in
Okay,
order
that
to absorb less current?
right, that I'm not very sure about because that only an industry can answer because
This
we
is
have not.
always under research in development lab, do you know?
Oh no, they haven't mentioned it anything about the power changes or using a different chip. They haven't exactly mentioned about that.
Okay, thank you very much indeed. I appreciate it.
Yes, thank you. Uh, Shruti said, "Isn't doesn't the LLM follow a decoder architecture?" Right. So it's a decoder architecture when you are generating the final text output. It's ChatGPT was a decoder only, right? But what I meant by encoder is like even see the way the encoder works in GPT is different. There is no encoder block, but the decoder itself is able to do the encoding with the specific with in terms of text for GPT I'm talking about. But in terms of other LLMs which are not GPT, they have their own encoder blocks. So those encoder blocks are used for the you know for generating the embeddings. And decoders are Uh, and what I meant by the encoder part was in the vision transformer that does not follow the LLM architecture.
Okay. Yeah, Akash, thanks. I just have few more follow-up questions.
Yeah.
So with other LLM models, not closed source models, but open source models like Anthropic or any other applications available online, what do you think would be the second bet other than ChatGPT?
Or you mean as an LLM, which would be the
Yes,
best?
yes, yes.
Okay, so there's something called Open Assistant, which is something that's very good. And there's also
Mhm.
Falcon. So Falcon and Open Assistant are two really great open source models that you can look at. Both of them perform almost similarly. Is that Falcon outperforms Open Assistant in certain problem solving tasks. So if you are asking for which is a better LLM, both of these would be good. They are both open source. But the thing with Falcon is that you can apply a layer of called there's this framework called the Tree of Thought framework. So
Mm,
the framework can be applied on Falcon. I'm not sure if it's applicable on Open Assistant yet, but
okay.
you can empower Falcon with that framework.
Okay. Yes, Akash. So following this, this might be a little off topic, but just talking about in-depth architecture of LLMs or ChatGPT for that case, when it comes to embeddings or chunkings,
Yeah.
I see that it is there is a lot of improvement required in that space because a lot of context gets missed sometimes due to this chunking and embedding. So, what is your thought on that?
Okay, chunking. Okay, right. So it depends on how you create your chunks. That is very important. So if you're talking about LangChain, so there is a character text splitter and there's a token text splitter as well. So you can split based on various characters. If you split based on like a good character, like if you use a good delimiter, right? Like let's say you use a comma or you use a space or you use a new line. So those are all good separators or delimiters based on which your chunks can be made better. And another way is called overlapping. You can use
Yeah.
overlapping. So like the last 100 or 200 characters will be repeated so that the model has made sure it hasn't missed anything when you're creating your uh,
Yeah,
input.
you're right. You're right. But if you say tokens, one token is considered to be a set of four characters or n characters based on the tokenizer that you're going to use.
Huh,
So
yeah.
even in that perspective, I think when you split it into tokens and then like exactly, absolutely, even we are using the same like chunking and overlapping and etc. But still, somewhere we see that the context, the question that we ask and the kind of response that you get is haywire or there is some lack of context during
Okay.
this space. I mean, I also
I think
yes.
one of the strategy would be to create an hierarchy where you have smaller chunks and then get a lot more detail from those smaller chunk sizes and then use those to again have a bigger chunk size to get the next level. So by tiering those kind of things could help.
Layering, you mean hierarchy? Okay.
Yeah, layering and then creating an hierarchy of different chunk size models. It'll take up space and all that, but might get lot better answer in the context.
Okay, I can try that. Thank you. Akash, back to you. Just one more last question. We have this moderation API and responsible API coming up for the security perspective from GPT 3.5, right? So you were saying in GPT-4 they have incorporated all this. So do you mean they have leveraged, I mean, uh, used more of this moderation or other prompts to secure such acts like jailbreaking and etc., or have they done any other, have they followed any other technique to suppress this?
Oh, okay. That's a great question. I actually was thinking if I should include it in the slide, but it felt like it was a lot of extra information. So thought I would explain it when a question came up. So yeah, good you asked. GPT-4, when they were doing safety and alignment, they first did RLHF and they said that, okay, RLHF is one way. So we pass it to the ARC and they will give us their feedback from it. The second thing is they also outsourced it to, they also hired a red teaming and a blue team. They had two teams basically, a red team and a blue team. So in cybersecurity, there's something called red teaming. So red teaming is a process where they hire certain attackers or like a hacker, which purposely tests your system's security. So they hire some people just to test the security of your system. So the same way, the OpenAI has hired people as they've hired a red team, and the red team has performed test and vulnerability testing and like, can your model handle insensitive prompts? What if I try to jailbreak it? What if I give my prompt in a very creative way? Will it still give me insensitive output? So they've tested all of that, and they've made sure that it does not give you any insensitive outputs. Because GPT
Okay.
3.5 had a lot of problems. So
Hmm.
red teaming was something they followed for GPT-4. And the blue teaming operation was to test and validate the outputs that came from the red teaming team. So yeah, it is a very elaborate process for GPT-4 because their focus was on safety and enhanced output. So yeah, if you're worried about, if you wanted to know how new techniques were used, it's RLHF, and the
Mhm.
second part was with the red teaming and blue teaming operation.
Okay. Thanks,
Yeah,
Akash. Thank you.
yeah, okay. Um, they're not planning to release GPT-5 in the near future due to concerns you listed. Right. So GPT-5, they are, I think even the OpenAI CEO said that it'll be quite some time at least before GPT-5 releases because they don't want to release it very often and make sure compromise on anything. They want to make sure they're solving a problem and then solving at least one problem related to safety and then solving another problem related to the evolution of language models. Only then release them. That's what GPT-4 solved, right? That's why they released GPT-4. So that's what they're focusing on. They're not focusing on releasing newer models right now. They're trying to focus on improving the current model. Yeah, they are using the model to solve business specific problems. Yes, that's very true. They have already, that's what I said. They're using it in Morgan Stanley to manage the finances, and they're using it in the Khan Academy app. They're using it in the Be My Eyes app as well. So yeah, it is currently being outsourced to products as a product. Okay. So yeah, so some known issues that GPT-4 possesses similar risks as previous models, such as generating harmful advice, buggy code, or inaccurate information. So inaccurate information, buggy code, these are two examples of things which were always there in GPT-3 and GPT 3.5. So you may not get, yeah, again, the code generation is not yet perfect. Your factual accuracy is not yet perfect, but it is slightly better. Harmful advice is not exactly, so this statement that was taken was in consideration with the early GPT-4 model. So there were two models called early GPT-4 and final GPT-4. So in turn context with early GPT-4, they had, this was still a problem, but they have solved that in the final GPT-4, which is what they've released as a countermeasure. So it incorporates an additional safety feature, safety reward signal. So there's a safety reward signal that is added to it during RLHF, standard reinforcement learning, with human feedback to reduce harmful outputs by training the model to refuse requests for such content. So any sort of insensitive request, it will refuse it. And it is, so this reward is provided by a GPT-4 zero-shot classifier. So this is just some technicality that they had mentioned about how the reward is provided. So it's not really very relevant.
I mean, there were guardrails before, but I guess
Yeah,
they
yeah,
were
yeah.
still not efficient. Okay.
So this is like some sort of some sort of metrics that they've shown here. So they've said that to prevent the model from refusing valid requests, they collected a diverse data set from various sources. So this was with including the human red teaming, model generated prompts, etc. And they applied the safety reward signal with a positive or a negative value on both the allowed and disallowed categories. So this is, they're describing the way that they handle the safety part of it better. So if you see here that the prompt type and the incorrect behavior rate, so the incorrect behavior rate for GPT-4 for disallowed prompts is very low. So that's something that is very important compared to the other models here, which are being shown. So yeah, so that's two takeaways from safety. important takeaways actually, because if you're considering to use GPT in your business and serving it to clients, then such problems should not occur. And GPT is saying that yeah, this is definitely reducing the incorrect output rate. So these are just some principles from OpenAI saying that how they will you know go ahead more further with safety rather than just releasing models with more performance. So yeah, this is the conclusions from the webinar and from GPT-4 in general. So GPT-4 is OpenAI's largest and latest multimodal LLM. It is one of the state-of-the-art models in all evaluation categories. So it is OpenAI is now focusing more on safety and concerns regarding harmful text generation. They have realized the competition around them, the scale of the competition around them, and if they did publish all the details regarding GPT-4, it should not be accessible to you or me to sit and start being able to train this kind of model without understanding the depth of safety that is required. So GPT-4 is now available to all paying customers via the chat completion API. Yeah, so it is now available as an API endpoint. You can use this if you are paying for the API key. And the vision to text feature is currently not available to the general public. It's still under testing. And one more final conclusion is that it was trained for longer with a cleaner data set with a combination of incorrect and correct solutions so that the model won't generate different answers each time per user prompt. So if you guys have ever mentioned or typed a prompt in a GPT-4 to solve a question, any sort of mathematical question, and it gave you an answer. If you said no, the answer is this, then it tries to generate the answer corresponding to what you asked it for. It was a very big problem with ChatGPT. So GPT-4 has said that it is going to restrict this problem. So it may not be able to restrict it fully, but in most cases, it will reduce the chance of it happening. Yeah. So any questions? That's all for the webinar today.
Sorry, Akash, I have any other question this morning. You made a very, really interesting presentation.
Thank you.
So the first question is about the current absorption for this kind of GPT-4, GPT-5 within the next years. Do you think that the development of the new chip photonic, the optoelectronics, should be made some big improvement?
Yeah, because if you because the so there's something with related to Python as well. So there's Python is a language which does not support multi-threading. That's one thing.
Yes.
And parallelizing these operations will help a lot when it comes to training machine learning models because it literally just it runs every operation on a single thread. If you could multi-thread, extend Python to multi-threading, and there's actually a new package which has been released, and they're trying to work on multi-threading. So there's something called a global lock semaphore in Python, which locks the thread when it's being used. So they are now focusing on the software side to use Python for multi-threading, which will enable it for faster training and better training with machine learning. And using a better silicon chip, which you suggested, will help in terms of power management and efficiency.
So for
Yes.
you, the best language is always Python in order to make this neural network and all the module for the code and the algorithm for the GPT.
The Python is not the best actually. It
Ah,
is the easiest, but not the best.
easiest. Yes.
Yeah. There is Julia and R, which people use, but Python is just easier because it has more support with packages.
Okay, thank you. And what about the language Rust?
Rust is brilliant. Rust is brilliant. It is actually a very brilliant language, if you ask me.
Yes.
It
Okay.
and it is very efficient compared to Python, like 80% more efficient. And Rust
Yes.
is where people are moving over now. Even all operating systems are being moved to Rust from C++.
And the last question is about the job employees. Do you think that this kind of artificial intelligence will made in the brief term period many laid off in each sector of the business?
Um, it can affect the lower level sectors of business. Like if you had like a task of asking someone to, if you're asking a human person to sit and file reports, or to sit and validate if a report is correct, or to sit and check if there are any errors, or some small tasks like that, which can be automated. Even
Yeah,
even right now, like web developers and app developers are might slowly start facing risks, because I can have a model do the entire thing for me. And there was a case where I should have mentioned this, but GPT-4, they passed an image of like a website diagram. So someone drew a website like how it should be on pen and paper, and he just gave it to GPT-4 and asked it to generate a website based on this in simple HTML, CSS. So yeah, the same way GPT-4 was able to generate the code for it. So that's what they showed during the demo. And yeah, so like web developers, app developers, unless they're like very, very skilled, then that sector might slightly start seeing some effect on their safety.
no, because there will be a huge impact with the human beings in this
Hmm.
case. So right now we are facing to call with some human beings at the phone when you call your company of telephone, satellite, and so on. But in the future, I can guess that always will be automated with artificial intelligence, and
Hmm.
so with robots, and then so is very, I don't know if it's dangerous or not, but did you know what is now the FDA approved for the Neuralink by Elon Musk, by the way?
Hmm. I'm not exactly very sure. I'm sorry. But yeah, that's something I could look into.
Okay, thank you very much.
Thank you. Any other questions?
So, Akash, so there was
Yeah.
this recently news from Google about their next model, which is they say try to combine the breadth of knowledge of LLMs and the depth of AlphaGo, or you know, do you have any insights on how that can be done, or like did they release any information, and how does that compare with multimodal?
Okay. I didn't hear your question fully. It got cut in the middle for me. Could you just repeat it?
Okay, so there was recently a news from Google about their next model, right? So, I don't remember the exact name, Gemini or something.
Okay.
So, which basically they say that they'll be combining the breadth of knowledge that LLMs has with the depth of Alpha Go or Alpha Zero, right? So those models will have deeper understanding of a specific problem, right? Um,
Hmm.
so I'm just asking, like, do you have any insights, or did you see any information from um, any of this saying how that can be combined, like LLMs with um, you know reinforcement learning to deeper understanding of
Oh,
uh,
yeah, yeah,
as
yeah,
well
yeah.
as how does
Understood.
as well as how does that compare with multimodal, right?
Okay, so yeah, I get your question. The thing is, you're asking for better, like, reasoning capability features, right? Better, stronger reasoning
Yes.
capabilities, right? So that is actually right now there is something called the Tree of Thought framework, which specifically is solving that problem. So it leverages language models to learn how to solve any problem, any decision making problem. It leverages a language model to learn that additional feature, because language models on their own can't solve certain logical reasoning problems. But tree of thought
Yeah.
framework, yeah, it leverages the language model to learn decisions and then make a problem and then solve a problem that is given
So
to it.
tree of thought is more of a prompting itself, right? So it's
Yeah.
not really like and I'm wondering if it is like if this Google, what Google was saying is more like during the training itself, like I I don't know
Okay,
exactly,
okay,
but I'm
okay.
just
Okay, okay, that is different. Yeah, that I'm not very sure.
okay.
Yeah, it's a very interesting take if they're doing it while training, because while training it just means that they're providing like a lot of, um, strong reasoning capabilities to the model. So they will have to provide high quality inputs to it. They'll have to provide the question that they want along with an answer, and like why that answer was correct. So they need to pass those three as a feature for strong reasoning capability.
Okay. So another question, yeah, another question I had was more related to I just got lost. Um, um, okay, if I remember, I'll ask probably. I just got lost actually.
No issue, no issue. You can reach out to me via the
Yeah.
message itself. Anybody, any other questions? Okay. Yeah, I think that's it for the webinar.
Okay, so thanks a lot, Akash. Excellent presentation as usual. Very well researched and deep dived. Thank you, audience, for joining.
I hope I was able to address everyone's questions. If you all still have anything, you can reach out to me.
All right, so thank you all for joining and giving your Sunday morning here, IST time. Thanks, Akash. Excellent presentation.
Yeah, thank you, thank you, thank you, everyone.